Hey guys, so welcome to the chapter where we're going to learn to use the Pythagoras Theorem to find the hypotenuse. So again, let's have a look at this particular right angle triangle here. So we have the A's and the B's and the C's. So remember, A and B out of the A squared plus B squared equals C squared can be either of the other two sides. And then opposite the right angled side, we have the hypotenuse, and that hypotenuse is always the letter C. So what we're going to do is we're going to use that A squared plus B squared equals C squared to determine how to find the C, which is the length of the hypotenuse. So let's have a look at a few questions. Okay, so this question says, calculate the length of the hypotenuse of the following. So we've been given a right angled triangle there, which has a value of 3 for one of the sides, value of 4 for the other, and we need to find the C, which is the hypotenuse. So let's work it out here. So step number 1, guys, is always write out the formula. Every time you write out the formula, it just makes it a lot easier to determine how to use it properly. So always write it out. Step number 2 is always give the different sides a one of the letters. So number 3 can be the letter A, number 4 can be the letter B. So that way it's an easy substitution when it comes to the actual question. So A equals 3, so let me write it out here as well, so there's no confusion. B equals 4, and C is what we need to find. Now, step number 3 is simply swapping the letters for the numbers. So we have A squared becomes 3 squared, because as we know, A equals 3, plus B squared becomes 4 squared, because again, we know that B equals 4. And then C squared is what we need to find. We have 3 squared plus 4 squared, so we have 9 plus 16, which gives us C squared. 9 plus 16 gives us 25, so 25 is equal to C squared. And then finally, we need to get the C on its own. Now again, this is something that we'll cover in a more substantial form in the algebra chapter. However, in order to get the C on its own, we need to get rid of that squared sign. So we take that squared over to the other side, and the opposite of a squared is actually a square root. So C is equal to square root of 25. Now C equals square root of 25 gives us a value of 5. So the final answer is A equals 3, which is what we denoted. B equals 4, and then finally C is equal to 5, which is what we had to find. Let's have a go at part B. Alrighty, so now again for part B, we have to denote some letters. Let's swap these numbers around. So let's make this B, let's make this A, and that always has to remain C. So let's again, step 1, start by writing out the actual formula. A plus B squared equals C squared. Then we have A equals 10, B equals 6, and then C is what we need to find. Step number 3, simply swap the letters with the numbers. So A squared becomes 10 squared, B squared becomes 6 squared, C squared, well, stays C squared for now. We have 10 squared plus 6 squared, so we have 10 squared, which is a 100, 6 squared, which is 36, equals C squared. 100 plus 36 is basically 136, equals C squared. Once again, we need to get the C on its own, so we have to take the squared over to the other side. Now, the opposite of a squared is a square root, so C becomes square root of 136. Now, guys, you can plug this straight into the calculator, and you will get a value of 11.66. So the value of C in this case is 11.66. Alrighty, so let's have a go at a couple more questions. So again, we have to find the value of C, where we have been given a couple of these values here. So once again, let's start with the actual, so let me just go back to the color white. So we'll start with writing out the actual formula. So A squared plus B squared equals C squared. A in this case can be 5, B in this case can be 4, and C is what we need to find. So A squared becomes 5 squared, B squared becomes 4 squared, and then finally C squared remains as such. So we have 5 squared, which is 25, 4 squared, which is 16, so we have 25 plus 16 equals C squared. 25 plus 16 gives us 41. C squared, well, stays there. And the next step is to get the squared over to the other side. Now, when we take it to the other side, it becomes the opposite, which is c, right now that we've gotten rid of that squared part here, equals square root of 41. Once again, putting into the calculator, we get 6.4. Now guys, I want you to pause the video at this stage because we've gone through 3 of these questions. As you can see, the working out is identical, so it's fairly straightforward. Now I want you to pause the video and have a go at the part D on your own and show me how to do the working out. Alrighty, so again, let's give them some letters, or let's start off with writing out our actual formula. So a squared plus b squared equals c squared. Then let's give them some letters. So we have a here, b there, and that's c there. So then let's write this out so there's no confusion. So a equals 2, b equals 7, c equals whatever it is. And then a becomes 2 squared, b squared becomes 7 squared, and then equals c squared. 2 squared is 4, 7 squared is 49, so 7 times 7 is 49. So 4 plus 49 is equal to c squared. 4 plus 49 is 53, equals c squared. Take the squared to the other side, becomes a square root of 53. And then square root of 53 gives us a value of 7.28. Were you able to get the same answer? Well guys, that brings us to the end of this particular lecture where we use the Pythagoras Theorem or the formula of a squared plus b squared equals c squared to find the hypotenuse. I hope that was helpful. Make sure you have got the worksheets, and I will see you in the next lecture where we're going to use the same formula to find one of the other sides. So no longer the hypotenuse, but one of the other sides. The calculations are pretty much identical, except we have to do one extra step. So thanks guys, and I'll see you in that lecture.